Welcome to the Easy Access 1 Project J1A. Project J1A to build a feature-rich multi-threaded Java-based email proxy filter from scratch. Welcome to Chapter 5. Today, we'll talk about filtering techniques. In order for a proxy to become a filter, we will have to interrogate the information stream as it goes through the proxy. At this point in time, we will be divulging from the concept of a proxy into the concept of a filter, where we will be manipulating information as it comes through. Let's talk a bit about SMTP, Simple Mail Transfer Protocol, Post Office Protocol, Systems Query Language, Structured Query Language, and Extensible Markup Language. Every piece of SMTP, POP, SQL, and XML out there is text. It really is just text. Some of it's going to be UU encoded, some of it's going to be base 64, some of it is going to be careted and XML and highly structured, but it's all text. Okay. Now there could be some control language in there, but it's essentially text, and we should be able to log anything in these four languages without a hitch using these techniques. In order for us to do our filtering, we'll be evaluating the socket volleys. Now, what's socket volley? Because I don't think there's a java.volley class. So a socket volley to me is like tennis. All right, and I need you to start thinking of communication over the internet a bit like tennis. The ball is served and it gets replied to. It gets rebounded. So volley, return volley, then information goes back and forth, and in these SMTP, especially what we're going to be working with, every line that they push usually gets some sort of response. And that's the way it'll be in the command structure of SMTP until you get to the data. Once you get into the body of a piece of email, then that isn't exactly how it runs. But the SMTP command structure is basically a conversation. Don't trust the read line. For those of you who enjoy using your buffered readers, for those of you who enjoy pulling standard out, or pulling the read line and getting themselves a nice quick line of input from a socket, I don't trust read line. I don't trust read line because of character. Is it 9 or 13? ASCII 9? No, 9's tab. I think it's 19, B1. Character 19 has this nasty, I got to check on whether it's 19, has nasty tendency of convincing you that it's the end of line, or actually even end of file sometimes. You can't be sure that the text coming through will properly terminate in character code 13 unless you specifically write code for it, or you're pushing byte arrays around. So if you want to use the read line in Java, the buffered readers, the input readers, you eventually will get caught at this. And furthermore, there is, to my knowledge, no way to control read line once you call it. Once it's called, that's it. It's called, you're waiting. And if the client just simply wants to hang you right there, you're there for life. So you will need to write or override or actually write your own read functions. We've discussed that a little bit in Chapter 4. And as usual, we need to test and ensure memory cleanup. All right. Now, I want to briefly go over where we ended up at the end of Chapter 4. We have our proxy project. Okay, this is a piece of software we've been writing. We have a client, and we have a server. And a server being a server only because he's waiting for the socket. So the client will initiate, the server will respond. So the client will connect to us on port 25, and then the other half of that connection returns to the client on a randomized port number, usually above 1,000. So usually it's somewhere in the 20,000s. I don't want to get too far into how TCP/IP works with socketing, but you come in on 25 and you return on some other port. And if you want to do a netstat in your command line or your command prompt, and you want to see what ports you're on, netstat-n would be a good way to take a look and see how your porting is set up. So our proxy project will then forge a connection on port 25 for us to the Exchange server, and the Exchange will return on some randomized port above 1000. Okay? What we did in our last project, and chapter 4 actually, is we hooked in a buffered reader so that we could log the information as it came through on the incoming ports. Okay? So we're reading the commands, and the returning information is typically not something we would log unless the return is a response to text. There's all sorts of bytes that are flying in that they're handled at a different level. But at our level, we were logging the information as it passes to the recipient. So the client pushes information to the Exchange, and the Exchange pushes information back to the client in the lower arrows. And then we also added multi-threading so that we could do multiple clients. All right. Okay, we're back in Eclipse, and here we are with our Java package, our proxy package, and things are going to start getting complex now. So I need you guys to really pay attention. I'm going to move right along. I'm not going to type this stuff. I'm going to copy and paste it from some of my work I've been doing here. So what I need you to understand at this point in time is I'm going to start disrupting these socket streams of information. So instead of just getting the information and handing it off to the Exchange server from the client, I'm going to evaluate what's going on. All right. Now this might seem a little archaic, and there's always going to be a better way to do this. But in order for me to evaluate the information, I have to have a place to push the information after I find it to be acceptable. I'm going to add a few variables. I'm going to add a variable called message line. I'm going to add a variable called pad, and the pad will be 10 spaces. I'm going to add a variable called mail from, a variable called receipt to, and a variable called command. All right. Now the message line is going to be, from your point of view, it's going to be a string that's going to be terminated by character code 13 that we're going to get from the client. Okay. The pad is a little down and dirty trick that I use, that I add to strings as they come through to make sure that the string has a value. I either have to test and check the index length of each string. First I have to check for null, and then check the length of the string, because if I do any substring operations on a string and I go out of the index array, I'll bomb out of my try loop, and then the game will be over. So it could be some innocuous error will happen, and I'll end up with a string that's not long enough. But if I pad it with 10 characters, no matter what string instruction I call on it, I won't get an index out of array out of bounds exception. Okay, so I'll be adding the padding to the end of some strings. It's harmless as long as you know what you're doing and you trim your information when you're done. It's simply a way to make sure that you don't catch a bunch of weird errors. My mail from string, that's going to be pretty obvious. Receipt to string, that's going to be who the email is to. And my command string is going to be part of my message line, and sometimes I'll be chopping part of the message to get the command, the SMTP command that I'm looking for. And these commands have to come in a certain order, so I'll know what I'm looking for, and you'll see that as I start getting into this. Okay, now I'm going to set up some, oops, sorry guys, I'm whipping all over the place here. Now I'm going to set up a output stream object. I just pasted that in there real quick accidentally. Okay, I'm going to set up an output stream from the client so I can talk back to the client now. So now I can directly talk to the client and I could return information to the client. And at this point, the reason I'm doing this is that I'm going to convince this client that I'm the email server, at least for a few lines. Now, the reason we do this is that there's a lot of nasty people out there in this world. If everyone were a saint in this world, we would not be writing this program. So I'll talk about strategies. I'll talk about some of the email systems that I've run into and some of the nasty people out there and some of the tricks that they have. But for right now, I need to get through the mechanics of making this work before I explain to you the tricks and the trade that the Nigerians, the Russians, and the Middle Eastern people love to use to get through our email systems. So we got our output stream, our output stream writer, and I wouldn't normally do this, but since I have full control, full autonomy, I'm going to make a buffered reader just because I don't feel like writing my own or putting together a more complex class in order to write a couple lines, because I don't need to write but a few lines out to the client to verify that I'm happy with how the client's operating. Okay, now I have my buffered writer, excuse me, and I'm ready to have my first discussion. And I'm going to need a couple lines here so that everyone knows that this is going to be a bunch of new code in here. Okay, now I have my buffered writer, and I am going to write out to the client. Keep in mind we're in the run. We are in the run module, so we've threaded out. We're talking to a multi-threaded client in a multi-threaded way, and I know the client has connected or we wouldn't be here, and I am going to send my identification to the client that I am an Exchange server. And this is a generic Microsoft response, would be 220 Microsoft SMTP mail service. There's all different ones. This one has worked for me consistently, that everyone believes that I'm a mail server. And buffered writer has to be flushed. All right. Now, here's where things are going to get dicey. Normally, you could do message line equals some sort of a buffered reader.read line, but given that we need to be able to control this data flow, and I can't have someone connecting 1,000 times and just never disconnecting. So I have to create my own function to read information. All right. So I'm going to create a function, a method called safe_readline. And in order to do this, I'm going to go down to the bottom and I'm going to create a new class, a new method called safe_readline. Okay? And it's going to pass the parameter input stream. Okay. String line. Okay, this is going to be the line of code that's returned. And I'm in a submodule. To me, this is a submodule, so I'm going to create a string called submodule. And then I'm going to have a return line. Bear with me. Sorry, guys. This is return line. Okay. All right. This is a very simple method so far, and now things are going to get very complex. Okay. We have to be in a try-catch loop to do this, but I want these variables to be available outside. So I'm going to have 2 byte arrays, the bucket and the message. If you remember from chapter 4, I use bucket and message, and what I'll do is system array copy to combine them together. I'll begin a try. And there's the rest of my catch. And you can see now I'm at what I call a submodule. It's not a submodule. I'll call it that. And this submodule we call safe read line. Now my timeout will be 20 seconds. And I'm doing this so that no one can connect to me and just grab a socket and leave it there forever. I'm going to create a heartbeat, which is the current system time. This is really just a review of chapter, what was it, 3 that we were doing this. And while we still have a heartbeat, okay, while the current time minus a heartbeat is less than the timeout. So while someone has talked in the last 20 seconds, we'll continue to wait for information. I'll tell the system to wait just a fraction of a second. Then if the input stream provides the system with information, I will fill the bucket. I will define the length of the bucket, and I will now fill the bucket with the byte array. It's probably going to be a one-dimensional byte array. I'll reset my heartbeat. I will create a new byte called a combined byte. The combined byte will be equal to the current message, which is going to be empty, plus the 1 byte that came in. Then I'll do an array copy, and we will combine the message into the combined. Okay, we will push this new message into the front of the combined, and then we'll do an array copy to push the bucket into the back of the combined. So let's say there's 1 byte in this combined at this point, or there's not, but say there's 1 byte in in the current message, and there's 1 byte in the bucket. So the length 1 plus 1 is going to equal to 2, so we'll have a 2-dimensional array byte called combined, and this line will push the first byte in, and this line will push the second byte in. And then I'll pull combined into message, get ready for the next loop. And since I have autonomy over this, I am going to accept character code 13 as a break out of this while loop. End my if, end my when, get my return line, and if I break out of my while, I'll know that I have a full line, and I'll convert the line to a string, and then it'll return the return line. Okay, so quick review. This method is very similar to read line, for instance, a buffered reader read line, except that I have control of the situation, and I have added in a heartbeat system so that no one can hold me at a read line prompt for infinity and crash my system. Okay, so this safe read line method returns a string, and we'll go back up here, and the message line will now be safe read line, the results of safe read line. Okay, I know that's going to be a lot for you to swallow right there, and you might have to go back, take this video back, and watch what I did, but I assure you this works. Okay, now the first command in an SMTP conversation is either HELO or EHLO. If you don't know a lot about SMTP servers, this is your time to go do research on SMTP servers. You could use the results from Chapter 4. And Chapter 4 results, I believe, are going to be the logging the multi-threaded logging project that we were working on for this. If you have an Exchange server running, you could set up that logger and generate yourself a couple, maybe 10,000 or maybe 100 email conversations, and just take a good look. And actually I have a number open here if you want to see one. Client log. Yeah, that's not a very good one. Client log 2. Here's a good one. Okay. And you'll have a connection That's actually like that. I don't think I did a carriage return. So this one's extended hello, hello or hello, and there's some information coming this way, and then it's a back and forth. All I really care about on this hello, hello, is the first 4 characters. I've done a lot of SMTP work, and whatever comes after HELO or EHLO seems to make no difference in the world what it is. You just have to say something. So as long as this letter is EHLO or HLO, I'm going to go with it. Okay. So I will write the command out, and I know there's a 4-letter command coming. Okay. So we pulled the message line. I'm going to take the message line plus the pad, and the pad was just a string of empty letters, empty characters, to make sure that I don't throw an index out of range array error, and go for 04, which is the first 4 letters, and I'll take it to uppercase so that I can do a string comparison. So I'll push that into the command, because I don't care what happens after the command, at least not on this line. So then I'll create a test, and I'll paste this in. So if the command equals hello, or the command equals hello, and if I throw this Boolean switch flag, which means not, so if I don't get hello and I don't get hello, then I'm going to log I did not get hello hello, close the socket, and return. Okay. So if he doesn't follow the rules, I'm not going to allow him to continue. This is your call at this point in time. You can write however you want to handle this. If you want to let this go and just go to the next line, you don't have to write this code. I use this because everyone who's got an SMTP server knows you have to play this game. All right. So then we're going to get to the next line, and I'm going to reply, and you can reply anything. So here you might, normally you actually use their IP address. I'm just typing this in here just for testing purposes. But I'm going to reply to his hello with HELO with 250. And if you want to go look up your SMTP response codes, but suffice to say 250 is the response for hello. Mail.superserver, which is just some name I cooked up, which means no difference to anyone. 250, hello, and this is basically I accept the fact that you have initiated an SMTP protocol request, and I am answering saying I am an SMTP server, most likely, and then I'm going to flush those bytes out to the buffered reader, and they will buffer. Okay, now after hello, the next line has to be mail from : all right, MAIL space FROM : and if you don't do it that way with any server I've ever dealt with, you will be disconnected right then and there, or at least you'll get an error. So I'll pull another line after I've given them this line, and anybody doesn't know that that's a carriage return line feed. I'm going to pull another string, and I'm going to take it to uppercase and pad it. So I'm going to be looking for what's the next thing that the client is going to ask for. And he's going to ask me to create a new piece of email on my system that matches the one on his system from a certain, okay? So I know that the next command, at least the next part of the message line, should be a command, and the command should be 10 characters long. MAIL space FROM : is 10 characters. All right. Okay, I'm going to paste a block of code here, so be ready for it. Okay, so after the command, and this command had better be equal to mail from, I took it to uppercase, so I don't have to do equals ignore case, mail from : and if it isn't mail from, then I'm going to bomb out into my command console saying that he hasn't connected correctly, and then I'll do a little debugging here saying, well, this is what he really told me. And then I'm closing the socket, and then we're done. And I'm going to exit this thread. So this is a multiple hurdle approach. So now he has told me who the mail is from. And if we didn't bomb out in this if statement, then I want the email address. So the email address is going to be the remainder of the string after the word mail from : So this line right here, mail from, the message line, substring starting at 10, going to the mail message, the message line to the length, and I'm going to get rid of any arrows. And I'll probably do a delimit on space. I don't want to get into this right now, but just in case, well, I really shouldn't have to. An email address should exist here in its correctness. Now, this would be a great time for you to say, hey, I want to run a test. Mail from index of @ sign. If index, mail from index of @ sign equals -1, then you have a invalid whatever, blah 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 blah, and you could return out of your code because that can't possibly work. You don't have an @ sign, and if you want, you could create some code .com or .net. I think you might want to not go down that road because there's an awful lot of domains, top level domains like .com, .net, .ws, .tv. But if you want, this is a great spot for you to say, hey, I don't accept email from .mx, .cc, .canada, .cn, .romania, .ru, Russia. If you're fairly confident that your email server should never ever get an email from anyone from Russia, or at least a mail from identifier from Russia, this is your place to do that. So I'm not going to do any of that right now because that could go on forever depending on how your email is set up. Okay. So I got a mail from. So I'm going to push out back to the client. I'm going to make it think, hey, you're talking to an Exchange server. Now this client really thinks he's talking to an Exchange server. And he's going to actually think that 250.210 OK, which is the typical response you'll get for a correctly formed email, mail from, is he thinks he's talking to a mail server at this point. So I'm going to flush out those lines. All right. Now, the next one is I'm going to pull the message line again and see what he has to say. I told him, hey, it's okay. I'm good with the mail from. Now, the next line you have to use, and please do your research on SMTP servers for this sequence of events. I know the sequence of events by heart, but you will have to learn them, or maybe you already know them. It's mail from, it's hello, mail from, and receipt to. That's the order. You have to do it in that order. So here comes receipt to. Command equals message line substring 08, which will always work because I've added 10 characters at the end, so it won't throw an index out of a range exception, and it'll be uppercase. So here comes the big paste. If the command is not equal to receipt to, then you're going to get this logged. This is going to be logged, and the socket's going to be closed, and this is going to be the end of our conversation. Okay. Now, obviously, I want the receipt too. Okay. And here we have the receipt to string is going to be populated with a message starting at character 8, going to the end of the message length, and I'm going to pull the carets off the edge if they exist and trim it. So that's going to get me the email that the message is supposed to go to. And another successful return. I'm going to tell it, I really enjoy you telling me the receipt too. You're all good. Tell me your next thing. Tell me your next story. And I'm going to pull yet again another line of text from the socket. And I'm going to get my next command, which is going to be the first 4 characters. And I know that the next command has to be data, D-A-T-A. If it's not data, then we're not going to be having this conversation. So the command better be equal to data. If the command is not equal to data, we're disconnecting. We're going to bomb out, log the error, close the socket. All right. And now I'm going to tell the client that I accept your data command. A 354 and a 354 command tells it that I'm ready. End your data with enter, period, enter. Control line feed, period, control line feed. And again, if you do any research into SMTP servers, you have to have these command characters because this email goes way back. So ending a line with a period by itself was the end of email. I don't know who will come up with that, but that's the official end of email. Okay. Now, I'm going to basically put the client on hold right here. It's going to be a number of milliseconds, and the client won't care about being on hold just for a little while. Now, I have used these lines of code that you and I have written together. About 4 interactions. The hello, or the hello, the mail from, the receipt to, the data command. We have all that ready to roll. Now, I'm at a little bit of a disadvantage because I've told this client that I'm an email server and that we're arranging to create an email for someone on, inside my corporate network perhaps. And I actually have to talk to my email server or the email server I'm talking to, and now I'm going to have to tell it all this stuff that they told me. I'm going to have to make that connection and say, hey, I'm a client and I know how to talk to you, and I'm going to give you this information, the same information that I was just given. So in the issue here is to not connect to my email server until I get to the point where I really need to. So way up here, you'll notice that I actually created an Exchange Server socket, an Exchange Server input stream, and Exchange Server output stream. So instead of connecting up there, why don't I move that connection down here? Because this way I can protect my email server against having any sockets open that it didn't even need to, because the client never made it to the point where they were legitimate. All right. Okay. Now I'm going to add a line of code. I'm going to drop a print stream at you. And my new print stream object, Exchange print stream. I'm going to create an input stream reader from the Exchange input stream here. And a buffered reader from the Exchange input stream. Got a print stream, an input stream reader, and a buffered reader. Okay. Now, I'm going to use a buffered reader in this case because I know my Exchange server. I know what it's going to say when I connect to it, and I trust my Exchange server, at least my server. I trust how it's going to react, so I'm not going to write any sort of heartbeat it out current line readers. And I could probably pass. I could use my function and do it, but I'm going to try to keep it simple for you right now instead of having these big blobs of code up here like I've done at you. So here we go. This is going to be simple. I'm going to talk to my Exchange server. My Exchange server print stream. I'm going to print hello, and then I'm going to pull the line of information back to it, and I'm going to redirect it into null because I know what it's going to say. Now this could be a bad idea, so you're welcome to change this and make sure that your Exchange server is talking to you. I'm just going to pull the line. I know what it's going to say when I say hello, and I'm just going to ignore the return. Then I'm going to say, hey, I got a piece of mail here. I'm going to follow the rules, my mail from, and there's my variable that I pulled up here, mail from. And then I'm going to read line, and I know what my Exchange server is going to say, so I'm just going to pull the read line. Then I'm going to push to my Exchange server who the mail's to, and then I'm going to pull the read line and redirect that to null. Then I'm going to say, you'll notice the pattern here, data, and I'm going to pull a read line again. Now we're all the way down to where we start logging. So now that he's connected, now you could take this print writer and put it up higher and start logging all this information. But I'm just pushing out standard out. The failure's just standard out right now. All right. So I've gone through all the code. Let's fire the engines. Made it through the compiler. I'll bring over a telnet session. All right. Now, I'm going to telnet to the local host, and you'll see the information, 220 Microsoft SMTP mail service. So my client really believes, hello, Jojo. Hello, Jojo. Hello, super server. Here's the 1, 2, 3 stuff that I had. Okay. So far, I am believed. So oh, there went my 20-second timeout. I wasn't quick enough. Let's do it again. Hello, blah blah, and I'll paste my mail from. He's okay with that. My receipt too. They're okay with that. Data. Type. Enter, period, enter, end. And I just got an email. And we're good. All right. So, right now, nothing has actually changed because we haven't done any filtering. Now we have exposed all the commands, and we have exposed the from and to address. And I won't get into this. Actually, is going to have to be looped, this receipt to, because of BCCs. But we will loop out the BCC later on. But right now, you could, in your receipt to, right here, we would break out equals a known address at my domain.com. Okay, and you obviously wouldn't code in all your email addresses here in your source code. You're going to want to pull them. This is where we'll get into JDBC, or probably, to keep it simple for you guys, I'll just drop it to a text file and pull the text file every time someone connects, and zip out known email addresses. See, this is where we'll get into email harvesting. Email servers from Romania, Russia, etc., etc. They'll make up emails and send them into your domain. They'll actually random name generators they'll create, trying to find email addresses that don't bounce, and they don't care because they'll say that they're from a domain that doesn't hardly exist or someone else's domain, and they will use this as a way to fish or harvest or blind box your email server, trying to get email addresses. And if they find one that connects, that says yep, that doesn't bounce or appears to be a legitimate email address, then they'll send spam to it later on. They'll build a database and try to sell it. Also, you can honeypot it, or it's really not honeypot, but a version of honeypotting. You could do unknown address. If there is a recipient to an unknown address, we could just write a OK and flush, and then we would just ignore it, and then have receipt. Let's say receipt 2, and then receipt 2 could be equal to nothing, and then loop it out, do a while, something like this. I'm not going to write all the code for it, but what I'm trying to say is that we could while the recipients, and if they try to BCC or CC about a bunch of people, we could recipient honeypot them into making it think that you're sending all these emails, and basically I'm just ignoring all these emails to unknown email addresses. This kind of takes into consideration that you have a pretty good grasp on your list of emails for your organization. This could be real devastating. This would be really devastating if you weren't keeping track of the emails in your organization, because they would just get directed to null. Or also a good time for you to terminate the thread. If they try to send you an email to one that doesn't exist, it's up to you to how you want to handle that. You could just terminate them right there, send them a message saying you're sending an email to an unknown email address. That might be bad, because now if they're sending an email to a known person and then they're BCCing an unknown person, if you terminate it, then the person who's supposed to get the email isn't going to get the email. And let's say it's actually a friendly and they just made a mistake. So that could be a problem. So anyway, that's where you would write all that filtering logic. All right, sorry I ran long, 40 minutes, but what I'll do is I'm going to start posting this source code for the end of each chapter on our website when I get everything hooked in together here. I appreciate you stopping by and being interested in our project. Make sure you subscribe. I'll have links set up for the previous and next chapters, and I hope you enjoy the Java code and what we can do here today.